Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about h264, h265 and h266. So let's dive right into it. Well, first we have to understand what exactly we are talking about. We are talking about a fact that uncompressed video files are humongous, basically bonkers, aka stupidly huge. To give you a context of that, think of it this way. A proper full HD uncompressed video file would be somewhere around 400 gigabyte an hour. So yeah, fundamentally even our hard drives cannot contain one full movie. So fundamentally that's not acceptable. So, and another aspect is for movie editing you may find a way to work on that kind of large file size. However, for transmission, that's a no-go. That's a flat out no-go. Transmission means everything, basically transmitting your video over YouTube, over Netflix, over satellite dish, because again it also has a physical limitation how much bandwidth it can send. So file size must be smaller. And when we are talking about small file size, we technically don't mean about in terms of how big the file is. We mean in terms of Mbps, basically how much bits it consumes per second. So because many systems are real time. Now, bandwidth, nowadays internet is with everyone. However, bandwidth is still critical. Fundamentally, think of it this way. Let's say you made a video website where it's like awesome video quality, but it buffers most of the time simply because it requires too much bandwidth, and somebody else made a compressed system, but it's super easy to load and buffer and all that. People will prefer because bandwidth efficiency is priority. You have to utilize the bandwidth you have. You cannot complain about it. You have to be like, okay, people want 4K, but they barely have 30 Mbps. You make sure you fit that puppy in 25 Mbps. So that's up to you. So fundamentally, bandwidth efficiency is key priority. It's like you have to take care of it. And real-time systems, for example, video calling, live streaming, live telecasting, all these things, all of them are digital nowadays, and they do not have the luxury of buffer. For example, if you are using let's say poor quality mobile 4G, and you are like, okay, let's say you want to watch that YouTube video in 4K, you play, it starts to buffer, you're like, okay, pause, let it buffer, and then you wait for that gray bar to load up, and then you watch the video. You can do that buffering in non-real-time system, but you cannot do that on a television, you cannot do that on a live streaming, you cannot do that on a video conference. So fundamentally it has to be very serious and efficient in real time, aka 1 second of video should take you less than 1 second to do things with it. You cannot be like, okay, this 10-minute video takes 1 hour to process or things of that nature. That's why this is very, very critical. Now, two things you will always hear about these things, and you have to be very mindful. Do not mix and match these two things: codex and container. Now, codex is a short form of compression decompression. So what the heck they are compressing and decompressing? It's basically talking about codex that has been utilized to compress audio and video data. Now, those are contained separately. So you could literally have one video that is h264 plus mp3. You could have h264 plus AAC. So be mindful. These two things are completely independent. So codex only talks about, okay, I'm going to take this data stream, be it video, be it audio, and I'm going to compress the hell out of it. And how the heck I'm going to decompress, that's into that patent, basically codex patent, so to say. So codex is like an algorithm. It's like, okay, I'm of this codex, utilize this dictionary to understand me, utilize this algorithm to understand me. That's all there is. So you compress it, basically while you are baking the video, rendering the video, you compress this puppy, and your player decompresses it. Player as in it could be a software player, or it could be a physical hardware chip on a, let's say, DVD player or Blu-ray player. So that's what codex means. Basically compression and decompression is just a language that allows compression and decompression with minimal loss of quality. Now, loss of quality is inevitable because inherently you are just guessing things. So fundamentally there is a loss of quality, but people try to, let's say example, quality is 100, your video was 100, you compress that puppy, size became equivalent of 10, but once you decompress it while you are playing that, the quality should go back to as high as, let's say, 70. Now again, that would be called a very efficient format, but right now what we have is more equivalent to take a basically 100 in video file, compress that puppy to 10, and your video playback efficiency is around 30. So that's what we are talking about. Codex is kind of a language, a dictionary. I'll basically use this language to understand me. Now, core algorithm and software, hardware, everything goes into this puppy. So when you are talking about, okay, h264, there is a hardware about it, there is a software about it, there is a virtual software that run on tops of a different uncompatible hardware, so to say. So if you are using old computers which does not have a dedicated processor device, so to say, in it, where it's like, okay, I'm going to use the hardware to decode it, it will still run because there is a package for it to manage it. So fundamentally it's a complete ecosystem. It's like how a language works fundamentally. Now container, this is a different thing. That's why I specified codex and container, they are different. Container is a packaging element because every video file that you have Normal calm video files, they have three core elements. First element is codec, so it has to know which exactly language you're using. Video stream, so that's what you're like, what your display should show. Video stream, okay, that's content number one. Then you have content number two, audio file, because you do not want a video file where it's like, okay, play this video and then directly make sure that you click these two play button at the same time, so the audio and video starts playing at the same time. It does not work that way. So you have to have a different independent audio file. So you have a video stream, you have a audio stream, and then you have metadata, basically who made the file, sign dates, extra detail and all that jazz. You have all these things which are independent. Fundamentally, how the heck you make sure your video players gets all of it? You pack that puppy up in a container. That's what's the job of .avi, very old system. .mp4 right now the most popular, MOV, OGG, FLV, MKV. That's what we are talking about whenever somebody says container. So container simply means a way to pack all these things in one place, basically audio, video and metadata. When you're packing all these things in one place, that's a job of a container. When you're talking about how the heck actually the streams are compressed, they each could have different codecs. For example, your audio codecs could be basically Windows Media Audio, it could be AAC, it could be MP3, PCM, your video could be basically VC1, h264 and h263, h265. That's up to you. So be mindful. That's why codecs and container, they are independent. Containers sometimes have extra bells and whistles, because there is one video container that has the luxury of thumbnails. Basically thumbnails can be encoded in the file itself. You will not have an independent file. That's amazing. So if you have a lot of video archive, you may want to utilize that container. And some containers also allow you to have subtitles, multiple audio streams, so to say. So go bonkers if you want to. So that's what we are talking about whenever somebody is talking about codecs and containers. Codecs is the language, container is basically the library with your audio, video, metadata and all that jazz. Now let's understand h264 and h265. Now let me be very clear. This puppy is very close to magic science. Basically the amount of algorithms, the amount of mathematics you have to understand to even comprehend what the heck is going on, it's way beyond my ability. And to give you a context of this, no single individual makes this. There is like a team of elite people who who know mathematics on a level where it's like, dude, you are not human, you are a computer at this point in time. They work on this. So fundamentally it's very, very complex. Like it will melt your brain. Now I provided video down below the people who went a little bit deeper than what I'm going here, but be mindful. If you truly want to understand this, like actually understand this, you really need some very solid understanding of mathematics. But to give a overall context, h264, this awesome codex, which is classified as advanced video codex. Sometimes you will see different basically video editors, video converters and all that, they will use different naming convention. So h264 could be also named as HEVC. It was made in 2003. Now you're like, wait a minute, that's old. Yes, that's old. This is like right after DVD and all that jazz. So that was made. And then h265, that was made in 2013. You're like, okay, that's also old. Yes, but they were like, think of it this way. There is an association that takes care of this, and they loan it out. Basically this royalty, they loan it out, and developers, be it your hardware developer, be it your media developer, be it your distribution developer, basically the online networks and all that, all of them start working on it. Some makes basically, if people are dealing with video editing software, those people will start working on making the codecs so they can export the file. Then the people who are working on players, they will make player compatible files. So you get the, like, there is a whole infrastructure that have to be built before even a single file comes into quote unquote normal day-to-day use. So that's why these years are so advanced. Like right now there's a foundation being laid of a new generation right now as I talk to you, but again we will not see it or hear it for 1 or 2 more years. Now 4K requires HEVC simply because media limitation compelled the developers of Blu-ray. Blu-ray was full HD, awesome. But when they went to 4K, they're like, okay, 4K will need more space. So they're like, okay, we'll go to basically the people who made the disc, and they're like, can you double the capacity from 25 gigabyte? They're like, yeah, we'll make double layer. Awesome, capacity double. Then they're like, yeah, we still can't fit it. Oh, okay, we'll make a third layer. Somehow they got 100 GB up to at that point in time, quad layer and all that, but still was not enough, still was not containing enough data. So physical media maxed out, we cannot pack more gigabytes in that. So what they do, they created what we call it high efficiency video codec. So they learned a lot from HEVC. Now be mindful, these things are advanced algorithm. So if you make a system that's like super advanced, super high compression and super good decompression, it will require a lot of silicon, aka a lot of what we call teraflops, as in like computational horsepower to decode this. And in 2003 when they built this, it was designed for 2003 kind of hardware. Basically, hardware will just become cheaper. When 2030, you have 10 years of Moore's law. You have like at least 2 generations of doubling the computational capacity, doubling the efficiency, halving the price. So you have enough oomph where you can do that. That's why it's not like, okay, new codecs came out, awesome, everything is gonna work. No, it doesn't. It takes time for that computational power to become cheap enough where it's in everything day-to-day life. So 4K needed that. So 4K Blu-ray players got that puppy first place, and then on software, basically on your desktop computer, it has more than enough oomph where it can simulate all these things on a software level, but it's not very efficient. Now, how the heck they are achieving higher compression while giving you better quality on a 4K system? How the heck that's happening? Simply because it is using better logic and blocks equipment. So h264 is a simple system. They take a frame and they slice that puppy up. In that slice, they use a mathematical function to figure out what is the noise pattern here, and based on the noise changes, basically high noise, they're like, okay, this place has beard, this place has hair, focus detail on this place, do not compress these blocks, compress everything else. Awesome, it does work, but here's the deal. It's kind of very brute force kind of approach. It's like everything has one layer, and then you do not compress the things that basically that have changes like hair and all that jazz. Now HVCC, it goes in 2 directions. It's like, okay, let's compress everything that is like not changing so much, but let's compress them on a much bigger block. So fundamentally, if this video is encoded in h265, which I will do, this whole section, if you go into a software level, it will like, okay, nothing is there, like, because it's not changing. Again, it's changing now because I'm moving my hand, but if once I remove that whole location is just coming as a software blank, like there is no data there. It's just like, okay, repeat this frame until changes happen. Change happened. Repeat this frame until change happens. So that's how it's basically working more on removing the complexity, redundancy. It's like, okay, if this is not changing, don't tamper with it. If this is not changing, don't tamper with it. So that's the whole point of HEVC. Basically, it's the same thing as h264 did, but more efficiently, because it has much advantage of basically much more efficient algorithms, much more efficient silicon. So you can physically run these algorithms. And that's why it became a successful thing. However, be very mindful. This thing looks very easy. Oh, we're just gonna make this puppy blank and all that. It's very computationally heavy, so to say. And if you have a video file that is working on 60 frames per second, it has to happen 60 frames per second. Now, deployment is also a very critical type. It's like a chicken and egg kind of scenario. You made a codex. It's awesome. It's super amazing. Everything awesome, but nobody utilizes it. It disappears. Has happened to many codecs. So fundamentally, you have to create a scenario where everybody utilizes it. So h264 AVC was bee's knees in 2003, and 265 became bee's knees in 2013. Now 4K needed that. So fundamentally, the ability to buy 4K disc required this puppy to work. So Blu-ray players, they had to figure this out. And soon after, after 2013 finalization, NVIDIA started to come out with Quadro cards that had dedicated chip to decode this puppy. Then over time, it became cheap enough where even low-grade graphics card started to have that. Now almost everything has that. So there is a step of deployment. So do not expect, like, if you see a codec that is being worked on today, it will not become mainstream in tomorrow or something like that. It will take time, 5, 10, or sometimes if it requires a lot of silicon, it will take a lot of time, or maybe specifically speaking, a lot of time to become cheap and efficient enough. Now, what we can expect in the future. Now, you have to understand this. h264 already made in 2013, and this is 2020. So in 2020, a new codex was finalized, that is versatile video coding. It is h266. That was just finalized a few months ago, so to say. Now, this puppy is targeting at 8K and 12K. Now, if you think those resolutions are bonkers, TVs are already being made. So you have to have a way to pipe the video stream. So they have to have this, like, it's already been developed. However, h265 was not as successful as people were hoped, because h264, it became widespread. Right now, almost every camera, every dash cam even has that. So it's fundamentally very widespread. h265 did not happen that. The reason, like, if everybody points down, like, what the hell went wrong with this, even though it was in 2013, and I'm reasonably sure most of you are watching videos about this and being aware of it like only 2-3 years ago. So why the heck it took so long? The reality was, it had a very bad royalty model where nobody was agreeing on anything. It's like, this company is like, no, for every equipment I sell, like basically every silicon chip I sell, I'll pay you 1 cent. Some other companies like, yeah, for every silicon I sell, I will give you 0.01 cents. It's like everybody was fighting. It was not an efficient system. So a lot of abuse happened, a lot of basically a lot of friction. So fundamentally, this time, the association that is dealing with this, they are like, no, we have to take care of this, and they created a sub-organization inside their organization that is going to take care of the basically budgeting side of things. So better royalty model for fast adoption, because if that fails, let's say a silicon manufacturer comes to, let's say Fastech Media is like, bro, I want to make this, and they're like, yeah, we'll get back to you with pricing after 5 months. They're like, yeah, I'm not waiting for that long. So this time they are working very hard on it. However, h265, while it was not mass adopted, so people started to realize something very interesting. What if we went to the model of Linux? Think of it this way. What is most common operating system on a server? It's not Windows, nor it's Apple. It's Linux. Why? It's open source. Nobody owns it. So fundamentally, open source works. So a lot of people are working, hey, what if we made open source codex rather than going to some association and we have to pay? There will be association that will be running on donations and direct contributions, but there won't be any requirement. It's like, hey, you want to make a chip that decodes this? Here's the specs. Go YOLO. So to realize that dream, lot of large companies, for example, Amazon, Apple, ARM, Cisco, Intel, IBM, Google, Facebook, Microsoft, Mozilla, Netflix, Nvidia, all of these they came together and they made this AV1. Now be mindful, AV1 was like a like a evolved form of VP8 and VP9. So the idea is the patent is very simple. It's like you can utilize this, it's open source, you cannot claim it. It's like even if you are using it, oh no, I made it, you cannot do that. That's a no. You can utilize it, you can share it forward, awesome, enjoy. And royalty free ecosystem is specifically created, and just to make sure that it's wide adopted, like again, each of these companies are huge enough. Each of these companies on their own have the luxury of like actually making something successful, but all of them working together, that's a serious force. And they have sub partners also, basically, like, the people who are pitching, few $1 million, not $1 billion, few $1 million, like VLC, you have Broadcom, you have AMD, you have Hulu, basically everybody who's actually dealing with audio and video. So lot of people are betting money on AV1. So right now Netflix is kind of like double betting. They're like, okay, if h266 becomes popular, it's like we already have a hardware for it, because again, they have to stream in 8K. They are preparing for it right now. I do apologize for the background noise. And Google and everybody else, they are working on AV1. And for sake of humanity, ideally you want AV1 to succeed, because you really don't want patents and all that, just because it really does not work. It fundamentally does not work. It's like so many complexities, like just does not work. So people want AV1 to succeed. However, because Google was like a primary investor on this puppy, they kind of figured something very unique with this AVI codex. It's like it's far more efficient at lower bitrate. So if you are making video calls like Google Duo, sometimes they utilize this algorithm. It's like for lower bit rates, basically like 8 Mbps or 10 Mbps, this has much better quality than h265 also. So it's really good. And compared to h266 is just finalized now, and AV1 is a bit far ahead in its development. So future is very interesting. I'm reasonably sure both of them will have some success, but over time you would want one to win out, because again, every hardware manufacturer is like, the moment you're gonna tell them, hey, build a Codex engine or for this and this, they're like, nope, choose one or pay more. So future is gonna be very interesting. So this was my presentation on video codecs. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.